Hey YouTube, what's up? Dr. T here in St. Petersburg, Florida. So today, as promised, I will go through my code for moving the agent in the Gridworld project I'm working on. Now here we have the first post in the live coding which showed you how to build the grid, and that actually explained the coding for putting this graphics interface together. And if you haven't been through this part, you probably should go there. Otherwise, it's maybe a bit more confusing. So we're going to go from here to the actual updated code on my GitHub. So I'll need the agent back. So here's the code. You didn't particularly look at this right now. This is just looking at things from outer space. So that was what we went through in the last post. Don't focus on the code right now, and we were going to be coming in to the function move the agent code, which is down here. It's mostly repetitious. Now don't look at the code right now. We're looking at this from a top-down perspective. So we're in outer space looking at Earth, and then we're going to move in, look at the continents, then we're going to move in, look at the cities. So I need to point out some elements that are significant and somewhat difficult to take in. This is the agent, and its coordinates from Tkinter are measured in the x direction, which is 70, and the y direction, which is 290. Now these are represented in vectors, and once again, don't look at the code particularly, but in this element here, when we're specifying this, 0 is x. And when x is 0, when s is 0, and s pertains to this element here, it's the first element in this agent's coordinates. So when s is 0, we are here. And when y, so it's even confusing for me. Y is 290. So when s is 0, where are we? We're further down here. We're down in the right move. When y is 290, we're here. So when the y vector equals 290, we're down here. So let me go through the perspectives of the outer views. Once again, don't look at the code. Now we're going to look at two directions. When it's moving to the right, it can move down here. When it's moving along this file, it can move into this grid here. Now, we don't want it to move into the wall, so we don't allow it to. But we do want it to move here. And in this part here, sorry, I'm confusing you. We're moving up. See, I've started confusing everybody right from the word go. Upward direction. Okay, sorry about that. So upward direction. So at this point here, we want the agent to move up into that grid here. So we're going to specify this with the extra code here, which identifies x at 400, 70, 180, 290, 400. X is at 400. We want it to move up to there. It's moving up in the y direction, and y starts off at 290, and we want it to decrease it. So that's why we are decreasing the vector. So don't worry about this code here. I'm just talking about the big open space, outer space position of the code. So that's moving up. Now we're going to move right. It can move down here. We're not going to allow it to walk into this wall, but in this position here, we need to move into the pit. So we will be specifying this point here exactly, which we'll be doing down here, so we can enable it to move into the pit. Otherwise, when it's moving right, it can move into its goal. So still in outer space, don't go anywhere. And we're going to do left. Left is moving down this pathway. It doesn't move into here because we don't allow it to. There's no conditions in which we're telling it to move here, so it won't move into there. Otherwise, it can move down here. So having moved in this direction, it can now move down there if by random chance it wants to do that. So that's the left movement, And the down movement is the same. It can move down here and it can move down there. So that's the big out of view, global view of what's going on. So now we'll move back into the code and we'll move down to look at the continent, so to speak. So we're moving a little closer. And I need my code back up. And we're going to run through what we're going to do. So we'll get rid of this first of all. So your objective, let's run off a few loops. Give you 100. Your objective is to run the agent and show that it actually does what it's supposed to do. Now it should reset when it reaches these points. It's not being cooperative like that. Now it's moved down here and into there and reset. We'll have to run it a few times to get it to do all these points. I just want to show you that it actually does do this. So it's moved up to there, moving to there. It's done that twice. Come on, be more cooperative, will you? It doesn't seem to want to be helpful. No. So it's random. Now it's moved from here up into here. And the last one we haven't seen is it move into the green. So see if we can get it to move to the green. Show you everything. Be cooperative now. Come on. Be cooperative. There you go. So it's moved into the green there and reset. And it will actually move up here into the green and reset. So you've seen all of these movements. See it come down here. Doesn't want to go up. Comes back in this direction. So I'm going to reset this. The other point I'll focus on is the coordinates. Give us a couple. Run that off. Move this out of my way. So our coordinates here, I've only got it printed out once. So the coordinates here are the coordinates we're dealing with. This is the whole coordinates for the agent. That's the whole of the coordinates, but we only need to deal with these two. So that's the x coordinate down here, 70, and that's the y coordinate down here, 290. So we want to see those. Now we can move on to the code itself and see if I can get it right without confusing everybody, including myself. So we define a function. It's called moveAgent. We need to bring the data to present the agent when we move the agent on the grid, and we'll be doing that. Let's do the top-down code bit. So we can remind you again, the class is Gridworld, and in order to have the agent move, we need to have the function operated. So we identify Gridworld conventionally. I call it data, and we print data, move the function we want to see. If there are other functions on there, you'll do print data into whatever other function you want to use. So it's print data move function, and that operates this taking place. So we've covered that. Now let's go back into the code from the top down. So we're bringing in the grid, and this is redundant. We probably don't need that. The time step will just shut the flow of time down by a small increment. You can set these as whatever is to your convenience. We do need that one. It's this one we don't need. So we do need the coordinates, and the coordinates I've got printing there. It doesn't need to be there, but I printed the coordinates out here because the vector is going to need to look at the specific aspects of these coordinates. So the next line is to actually get it to randomly move the agent. So for that, we're going to move a function which is random choice of this list here. So this will randomly pick one of these out at random. So, and then we'll move on to the code. If it selects up, now this is the exact equivalent. If move exactly equals up. Now the first instance we're looking at is if this is x, if x equals 70, that's down here. So if x equals 70, that's where we're starting off, and we're moving up. So we're moving up in this vector here. So x measures this way. This doesn't change. X is 70 all the time. Now, x is different over here, but we're starting off here. So if x equals 70, now we're moving up in the y direction. Now this is where it gets confusing. Y starts at 290, so we're starting off y here is 290, and we're moving up, so we'll go 290, and the displacement is 110, so it's 290, 180, 70 off the screen. Well, we don't want to move it off the screen, so we specify if S1, which is these coordinates, that's the printing out the coordinates, if S1, which is this element here, which is the y coordinate, if S1 is less than 70, which means if it's in this state or this state, that's the 290, the 180, then you can move the agent. It's going from 290, 180 to 70, so we want to decrease it. So this is our vector for using the move function. So we've got two numbers. This will operate in the x direction, and this will operate in the y direction. And we use this line of code to move the agent. So it's silly canvas. Well, this is calling our canvas. Self canvas is the canvas. This represents the canvas itself, which is this whole entity here. And then we apply the coding elements of tkin to do things in that environment. Where was I? See, it's very difficult to easy to get confused here. All right, we're doing the move. So if you go and, can I put this in there? Let's just do this so we can see it. It's a little less confusing if you can see something. And when you're coding and you put this in, you're going to have a selection of things that you can use. Now we're using move. When we built the grid, we used text, we used rectangle, and we used oval. So that's where these come in the coding environment. So just want to show you that. So we'll take that out. Put this back. Make sure I go slow enough so I don't get myself confused as well as you as well. So in order to move the agent, the coding environment is to select move agent. It requires the agent's specific information. Now the agent's specific information, well, actually it comes from up here, from the grid. So the agent's specific information are these coordinates. So we're telling it the coordinates of the agent in this position here. And it wants to know how much do you want to move it in the x direction and how much do you want to move it in the y direction. So this vector here is telling it to move nothing in the x direction and to deprecate it in the y direction. So it will change x nothing here and y something there. And that's that. Did we not get to see that? I wonder why it didn't. Oh, it didn't move. If you be nice. Well, I'm just going to throw this up a couple of times, one more time, just to make sure we actually get something on the screen so you can see it. So here we see it now. Move you out of the way. So it's done its move, and we can see how it's applied it. It's moved. It's actually moved. It's moved to the right, which is beside the point. But in moving to the right, it's moving the x direction. So x would be going from 70 to 180. So in this case, it's operated on moving x here, and it's not moving y. But it changes these vectors, and I just wanted to show you that. So coming back to where we are in the code itself. So that's the operation of this vector 0 and 100 moving the agent. So that's that line of code. That's what it does. And you can specify how much you want to move it by in your own world, doing whatever you want. This is the vector you're going to tell it to move from. You can be moving bits around the screen wherever you want. Then we want to get the chords. So this is the line for getting the chords from there. It's one of those other elements, .chord, self-agent, and then it will print out the chords. And these are the chords being printed out. You don't need them in here, but I'm printing them out. Then self-update, self-canvas update updates the code so that it knows what it's just done, and it can do that. Now we're going to move on to the next block. Now it's moving up there, and we need it to move up here. So we specify if the x direction, which is S0, equals 290. It starts off at 70, goes to 180, goes to 290. If x is 290, we want to move it up in the y direction. We want to move it up in the y direction without it going off the screen. right? So as before, the block is the same. So if S1, which is this coordinate, is this vector coordinate here, if S1 is greater than 70, i.e. it's 290 on Y, 180 on Y, 70 on Y. If it's greater than 70, then please move up, as in this case here. So once again, that little block of code is the same. It's just getting these other little things right. We want it to move up in this direction. So once again, we specify if now x equals 400, so 70, 180, 290, agent's 400 here. If it is 400, we want it to move up, and once again specifying that y should be whatever is necessary. We're just going to use the same data, less than 70, move the agent up in that direction. It's moving into a terminal state, so we now want to flag that and reset it. So we do that down here by saying if x0 equals 400, if it is in this state and we are moving up, we know we've reached a terminal state, so please reset the agent, and that will then bring in the reset. Oops, where are we? It'll be bring in the reset function. The reset function deletes the agent from the screen. So this piece of code, self-canvas delete, identify what is deleting the agent, will now delete the agent from that screen. We want to put it back, so we'll give it the coordinates for the agent, we update the screen, and it brings it back over into this point here. So moving on, if I can do this without screwing up. So we've come through that sequence. Now the right is going to be pretty much similar, apart from the fact that the vectors are going to change. But these things can be confusing, so if it selects move right, what does right mean? Well, it's moving down here, right? Y is not changing, X is changing. X is 0, Y is 1. So if Y equals 290, which means Y is here, it's not there, it's not there, it's down here, it's at 290. And if this is X is less than 290, we don't want it to go off the screen. Once again, X starts at 70, 180, 290, 400, off the screen. This is 290. So if X is less than 291, which is a little bit beyond that, if it's less than that, which means if it's in this position, you can move to here, but we don't allow it to move off the screen. So that's what this block of code does here. It's just setting these up here. You've already got that. And we're moving this in a positive direction. So here we've got the x coordinate in this vector and the y coordinate in that vector. So we're adding here, and as we saw this move here, we're adding 110 to this, adding 110 to that. But we're only interested in these two numbers because we don't need to bother with those. So we're moving the agent down here, and as long as it is less than that, it'll move it down here. It'll move it into this block, but it won't move it off the screen. Fortunate for us. And so we started off with y equals 290, and we're moving it to the right, and we want to see get it to move down this coordinate here. I've left the special for last. So y is 1 equals 70. So y starts off at 290, 180, 70. So when S1, the vector coordinate for this point here, equals 70, y is here, and we want it to move down the right direction. So we once again specify that x needs to be greater than 290, 1. Put your own numbers in there, but I selected that. You can move the agent. So once again, it's doing the same thing, only now we're coming to a terminal state, and in that terminal state we flag the terminal state. So if the x coordinate is 400, reset the agent. And now for our special case, where we want to move it to here, we're identifying this exact point. So we're going, if y1 equals 180, so y 290, y 180. So if y is 180 and if x, 0 is x, is 290, so x is 70, 180, 290. So if y is 180 and x is 290, we're in this position here. We've just specified that position and we're moving right. So now you can move into here. And once again, code's the same. It moves into here. It moves into a terminal state and we want to reset it. So once again, if x 0 equals 400, so 70, 180, 290, 400. So if it's in its 400th position here, we reset and we go back to bringing it out down here. And then the other two blocks are just simple because they don't involve that. So it's just a matter of repeating the same. So for left, we're moving left. So we're moving left and right. It's in the same place, left and right. So y is not changing. If S1, which is y, equals 290, y is not changing, x is. And x0 is greater than 70, 400, 290, 180, 70. We're moving it to the left. We do not want it to come off screen, so as long as that coordinates are greater than 70, you can move it. Otherwise, it will fall off the screen. We don't want to do that. It'll operate that, and it'll tell us in the code further on that it's done that, but that doesn't apply here. So, moving along, once again, confusing between x and y. So, if y1 equals 70, y is 290, it's 180, it's 70. We're in this quadrant here. Y is now 70. And we're going to be moving from the left. So if the agent has wandered around here and he wants to move to the left, it'll be in this position and it'll know that y is 70. And as long as the x vector is greater than 70, which is here, it can move down that pathway. So it can move from x 290, 180, 70, but it needs to be greater than 70, otherwise it wanders off the screen. Data's the same. And the same goes for the down direction. Once again, we're moving up and down. We're going to be dealing with these two files. So we're moving up and down, up and down. X is not changing. So if S0, which is x, is 70 in this file here, and if y is less than 290, I've got to stop and think here because even I get confused. I'm going to stop this for a second. Okay, I'm back. Now, y is going to go from here, 70, to 180, to 290, to off the screen. So we need y to be less than 290. So if it's 70 or 180, it can move. If it is, and as long as it's less than 290, it always comes off the screen. So I just happen to use that number. So as long as y is 70 or 180, it can move, and that's what that does. Same as before. Now we're going to move over to the last step, where we're looking down this file here, moving up and down, where x is 290. So if x equals 290, and once again, if y is greater than 290, so if it's y is here, greater than 290, it's 180 or 70, it can move down to here, and we allow it to do that. And that is it, ladies and gentlemen, boys and girls, that is it. That's the code in its entirety. I hope I went through this clearly. I went through it slowly. Where am I? The code is up on my GitHub. So I'll leave you a link to that so you can go in and get the code, and then you can use that for your own uses in your own projects. And so we've now been through the coding for drawing any kind of graphic that involves the use of rectangles, or in the use of lines, in the use of ovals, and in the use of text. These numbers appear on the grid here because I set them specifically. Further in the code we'll be bringing in something else here which will be picking it out from another function, but I've set these all to 0. So we've brought the text bit in there, so we've covered that. And I'll put this up on below and in the YouTube vid. So I hope that helps you. It's been a long session, but there's a lot to go through and it's difficult. So next time we'll be coming through with the final part of this project, and that will be how to get the data that it picks up and move it around through the loop and finish the Gridworld project.